So, good morning. In the previous class, we have started the effects of current in physics, and we have seen up to Thomson effect and the Thomson coefficient. In this class, we are going to see another effect is called chemical effect of current. So, we are separating the four fields. Number one is heat produced due to current. The second one is called thermal effect of current. The third one is called chemical effect of current. The last one is called magnetic effect of current. Electrolyte, we already seen in the second unit itself in a EMF. What is internal resistance? What is internal resistance? The resistance offered by electrolyte. What is electrolyte? The substance which conduct electricity because a fraction of their molecules dissociate into positive and negative ion. For example, if you are taking sodium chloride solution, it is electrolyte. Sodium plus ion, chlorine minus ion. So that is happening when a current is passes. That is a effect. Example, acid, all acids, bases and salts. Sodium chloride is a salt, H2SO4 acid, and also base, any KCl like that, anything we can take, which ionize when dissolved in water. Ionization means we are removing separation. Electrolysis, the process of chemical decomposition. What is electrolysis? Electrolysis is nothing but a process of chemical decomposition of an electrolyte into its components when a current is passed through it. What is happening? For example, chemical recomposition. If you are taking two electrodes, one is a cathode, another is an anode, two plates, whatever may be thing, it is given in the circuit. If I take copper sulfate solution, copper positive ion, sulfur negative ion. This positive copper is deposited on the negative plate. So, the negative comes to positive. This process is called electrolysis. Faraday's law, Faraday was a man first did so many experiments and he formulated with a law. That may be also one problem. The first law, the mass of substance deposited or liberated at an electrode is proportional to the quantity of charge that pass through the electrolyte. Why I already told you that in the experimental part, first you have to clean the raw negative terminal, dry it, and we have to find the mass of that plate, negative plate. Then it is again inserted in the electrolyte, the switch is on. The current is passing through the electrolyte. Therefore, the copper is liberated and go and attach to the negative plate. Therefore, the copper is actually deposited. Again, we have to remove the negative plate and again find the mass. We can find the things, the mass may be increased. So, how much the mass of copper deposited is that can be easily found out. So, that the mass of the copper deposited actually directly proportional to the charge. That is no current, because we know I is equal to Q by T or Q is equal to I into T. Therefore, M is equal to ZIT. What is called Z? Z is a constant known as electrochemical equivalent of the substance, ECE. ECE depends upon the solution itself. That will be given in the problem. We need to bother about it. Therefore, the mass of the copper deposited always equal to ZIT. Here there are three parameters, M, I and T. Anyone may be given. You may ask other. That is a possibility. So the first law, M proportional to Q. You have to keep your mind. Q, we know I into T. Therefore, Q proportional to I into T. The proportionality can be removed by a constant Z, the constant known as electrochemical equivalent. Okay. Faraday's second law, very similar experiment. In the first experiment, we are taking copper sulfate solution, two metal plates. In the second law, so everything is keeping constant. The solution is changed. First copper sulfate, then silver nitrate, like that. Then also we have to find out the mass of the copper deposited. The mass of copper deposited, there are first solution M1 is the mass, second solution M2 is the mass, E1 is the chemical equivalent, that is not electrochemical equivalent, this is the chemical equivalent of the substance, chemical equivalent, that means or equivalent weight, whatever may be the thing. This E is called equivalent weight or chemical equivalent. Then M1 by M2 is equal to E1 by E2. That is also M proportional to E. What does it mean? Mass of the copper deposited and mass of the substance deposited also directly proportional to the chemical equivalent. Or M1 by M2 is equal to E1 by E2. So you have to keep these two formulae very important. First one is M is equal to ZIT. Second one, M1 by M2 is equal to E1 by E2. These are the two laws which leads to Z1 by Z2 is equal to E1 by E2 or E by Z is equal to constant. Where E is called chemical equivalent, Z is called electrochemical equivalent. The ratio of chemical equivalent and the electrochemical equivalent is always constant. This constant is called Faraday. What is called Faraday? That is not in our syllabus. When you go to central syllabus and the NEET examination, they may be asked this type of question. What is the value of the ratio of Z and E? That is E by Z or some constant. That constant is called Faraday, capital F. It is the quantity of charge required to liberate one equivalent weight of a substance and is equal to 96,500 C. So this is Coulomb. This is actually the weight of a substance and is equal to liberate one equivalent weight. That is F is equal to N into E. 1 Faraday is equal to capital N into E. Capital N is called Avogadro number. You know 6.622 10 to the power minus 24 into E charge of an electron 1.6 10 to the power minus 19. So this is the thing we have to 96,500. That may be asked sometime. Then moving charges and magnetic field. So last topic we are coming now. What is called the magnetic effect of current. The magnetic effect of current, we are having more point to be noted. So just now we have finished what is thermal effect as well as the chemical effect. Chemical effect only Faraday's law. Two laws and what is Faraday. 1 Faraday is equal to Z by E. Z by E is a constant. That is a thing we know. The moving charges or magnetic field or magnetic effect. Once we know the magnetic effect, whenever the current flowing through any coil or any circuit or any wire, automatically magnetic field is produced. Very easy to produce magnetic field. We easily available the electric field. This electric field made to pass through any wire, automatically it is surrounded by magnetic field. The magnetic force on a charge Q moving with a velocity V in a magnetic field B, F is equal to Q into V cross B. What is actually here? That is a Lorentz force. So take a 3 axis. This one is X, this one is Y, this is Z. So we have to take the magnetic field always along this axis. You have to keep your mind. If any body or any charge moves with velocity V, this V can be resolved into two components. V sin theta and V cos theta. So that is actually happening here. V, that is V. That is resolved into V sin theta or V cos theta, which makes an angle here. Right. So the charged particle moving with velocity V means it experiences a force. This force is always in this direction. This force is called magnetic resonance force. Therefore, the force F is equal to Q into V cross B. Don't forget it, very important force. Then what is magnetic resonance force? Sometimes we have to understand the definition also. What is magnetic resonance force? When a charged particle moving in a magnetic field experiences a force, that force is called Lorentz force. Immediately Some doubt flashed in my mind. If I place a charge only, not in motion, any charge placed in an magnetic field, it should get a force. Definitely it won't get. The charged particle should be in motion, then only force will be available. Therefore, F is equal to Q into V cross B, or magnitude alone, F is equal to B QV sin theta. Don't forget it. This force called Lorentz force, whenever a charged particle moving in a magnetic field, they have a force. How much force? B QV sin theta. What is a magnitude? Q into, that is a vector idea. The direction of this force, I put to Y. This direction of the force can be understood by Fleming's left hand rule. Fleming's left hand rule. Left hand means we have to keep all the three fingers. That means thumb, forefinger and a middle finger are mutually perpendicular to each other. Then the forefinger represents the direction of the magnetic field, and the middle finger represents the direction of current. Whenever the current flowing through the conductor, magnetic field is the motion of a charge. What about the thumb? Thumb indicates the force. That means our motion of a conductor. So be careful. This is given in this chart. The magnetic force. A stationary charge not experience a magnetic force. Magnitude of the force. Magnitude, TUD. Magnitude of the force, F is equal to BQV sin theta, not U. BQV sin theta. This is the magnitude of the force. F is equal to BQV sin theta, not U. And the direction is given by the right hand rule. Right hand screw rule, also found by Fleming's left hand rule. Don't forget, right hand screw rule. So we have to tight anything or tight a screw. We have to use a screwdriver. So we have to tight it. What happens? We have to move the screwdriver like that. The direction in which the thumb turns, that is the direction of the force. Or Fleming's left hand rule, just now I have given. So this is a thing of modification. Moving charges and a magnetic field, magnetic effect. Just now I have told about the Fleming's left hand rule. Hold the left hand such that the forefinger, the center finger and the thumb are mutually perpendicular to each other. If the forefinger gives the direction of the field, magnetic field, just now I told, center finger gives the direction of velocity. Velocity means the particle with the motion. That means current. For positive charge, then the thumb gives the direction of force here or motion of a conductor. The force on negative charge is opposite to the thumb. That means I have given in the diagram, if the force moving outward direction, positive charge, if put inward direction, negative charge. Therefore the magnetic field B is equal to F by QV sin theta. So the F is equal to BQV sin theta. Just now we have the Lorentz force, F is equal to BQV sin theta. Just now we have seen. From which I want to find out the magnetic field or magnetic induction. B is equal to F divided by QV sin theta. That is called magnetic induction. Newton, ampere per minus 1, meter per minus 1 are usually the unit given as Tesla, Tesla. Otherwise it is also called ampere turns per meter. So many things are there. Ampere turns per meter. So we can keep this Tesla is sufficient. Then magnetic flux. Once we know about the moving charges, we should understand about the magnetic flux. Because if you are thorough on this, then only we can know what is electric flux, what is magnetic flux. Both are phi. The symbol is phi. What is magnetic flux? Magnetic flux is always a scalar quantity. The magnetic flux is the number of flux lines crossing the entire area. Flux passing through a plane surface of area placed in a uniform magnetic field. So I put a parallel line. The parallel line indicates that field is uniform. Then phi is equal to B dot A or BA cos theta. Or varying magnetic field, non-uniform magnetic field, phi is equal to integral of B dot dA. So generally BA, that is a uniform magnetic field, BA cos theta. How can I understand whether it is uniform magnetic field? If the lines are marked parallel lines, if the parallel lines are there, we can come to the conclusion that it is a uniform magnetic field. If it is not parallel lines, that is non-uniform magnetic field. If it is a non-uniform magnetic field, we can able to find out the magnetic flux in terms of integration. That is integral B dot dA for non-uniform field. Unit Maxwell. So there is actually magnetic flux. We are using Weber. So here or Maxwell. 1 Weber is equal to 10 power 8 Maxwell. Usually we are using Weber alone. But unfortunately in some central government NEET examination, they may be asked in terms of Maxwell. We have to know the conversion factor, that is 1 Weber is equal to 10 power 8 Maxwell. Since the direction of magnetic force is perpendicular, this is not friction. So kindly mind. This is direction dI or ECTION. Since the direction of magnetic force is perpendicular to the direction of motion, no work is done. What is the meaning of that? So just now I have told you that the thumb indicates the direction of the force or direction of motion of a conductor. The direction of the force as well as the direction of motion of conductor are in the same direction, means they are parallel to each other. Since they are parallel to each other, what is the angle between them? 90. We know work done. Fs cos theta, therefore cos 90 is 0, therefore no work done is there. Kinetic energy or speed of the particle. The magnetic force only changes the direction of the motion. No work is done. Work is done, but we have a force. Because of that particular force, we are getting kinetic energy, but not change in kinetic energy or speed of the particle. The magnetic force only changes the direction of the motion. Very similar statement for your circular motion. The circular motion also, the velocity is not uniform, but anyhow the direction of the velocity continuously changes, then they become a circular motion. Just like that, the charged particle moving in a magnetic field always circular motion. That indicates that clearly. That is called trajectory of a charged particle in a magnetic field. What is called trajectory? Trajectory means the path followed by the particle. Various paths they may be attained. Because we know just now we have seen the value of force F is equal to BQV sin theta. If case 1, if the direction of velocity is parallel or anti-parallel to B, the direction of velocity. So in previous case, just go through the diagram. This is the force, this is the velocity. Am I correct? This is field. The first case, if the direction of the velocity is parallel or anti-parallel to B, the body is not moved like that. If it moves like that, what happens? Parallel or anti-parallel. This is parallel, this is anti-parallel. Then theta becomes 0 or 180. Therefore, force becomes 0. What is the reason? Because BQV sin theta. If theta 0, everything is also 0. Therefore, F is equal to 0. Hence, trajectory is a straight line. Because the angle becomes 180 degree, the charged particle moving in a straight line. Case 2. If the velocity is perpendicular to the B, so this is B. If the velocity is along this direction, that is perpendicular to B, then theta is equal to 90. So in our example, that is theta. The first case, theta is equal to 0. If it comes in this axis, then the angle between the magnetic field and the direction of motion of the velocity is 90 degree. And the force has the maximum value because sin 91 Therefore, F is equal to BQV. Here F is equal to BQV. The trajectory is a circle. If both are perpendicular to each other, that means the direction of magnetic field. The direction of magnetic field won't be altered. It is always along Z direction. The motion of the charged particle may be varied. The motion of the charged particle parallel to the magnetic field. Parallel or anti-parallel. Then theta becomes 0. Sin 0, 0. Therefore, force becomes 0. Since force is 0, theta becomes 180. Automatically, what happened? They are straight line. If theta is equal to 90, sin 90 maximum value, therefore F is equal to BQV sin theta. Sin theta value 1, therefore BQV, that is a maximum value. The path followed by the charged particle is always circular. That is the second case we have to understand it. The case 3 also very important. So we already told that if theta value 0 and theta is equal to 90, if theta is equal to not equal to 0 or 90 degree, what does it mean? Just I have given a diagram. It is B. So suppose velocity is like that. That may be at an angle theta. Here we are having the value theta, but this theta value not equal to 0 or theta value is not equal to 90. The particle moves in a helix. Helix means the rotation in a coil. That is called the helix. V sin theta. Therefore, generally V sin theta. That is a direction. This is a V sin theta. This is V cos theta. V sin theta component perpendicular to B. So I already told that this is V sin theta. This is V cos theta. V sin theta component is perpendicular to B, makes the particle move in a circle, and the V cos theta component parallel to B makes it move in a straight line. The superposition of two motion is a helix. Are you understanding here? Very similar to that of tangent law. So, if the particle at a velocity V, the direction of velocity not equal to 0 or 90 at any angle theta, this velocity resolved into two components. V sin theta along the x-axis, that is called horizontal component. Here V cos theta along the y-axis. What happened? If V sin theta we are taking, it is perpendicular to B. When theta perpendicular to B, what happened? 90 degree. 90 means maximum value. Therefore circular. It is parallel to cos theta component parallel. Parallel means theta 0 or anti-parallel. The value F becomes 0. F becomes 0, straight line. So, this component makes the motion of the body in a straight line. This component makes the body in a circle. Therefore, they have a helix. This is called helix motion because both the forces are experienced. Both straight line as well as the circular motion will be there. Be careful. This is additional portion. Then what is the frequency of revolution of a charged particle in a magnetic field? The frequency of charged particle, what happens here? So this is also I have take that thing. So for understanding I draw this diagram. So this is x-axis, this is z-axis, this is y-axis. I have a magnetic field of induction V along the z-axis. Suppose I take a particle, charged particle P. It is in the xz direction. What happened? It experiences a force along a circular. The force direction inverse. If I take it here also, what happened? This is also have a force towards the center. So if I have R position, here also take a force towards the center, centripetal force. We know the Lorentz force F is equal to BQV sin theta. Here theta 90 degree because it is circular motion. Therefore F is equal to BQV. That's all. The force which is responsible for circular motion is called centripetal force. Centripetal force. We know centripetal force mv squared by r, where m is the mass of the charged particle, r radius of the circular motion, v velocity. Therefore both are same. Therefore mv squared by r is equal to bqv. This v getting cancels. Square. Therefore, mv by r v by r is equal to bq by m. These steps you are supposed to be known. We know the relation between the angular velocity and the linear velocity r omega. R omega is equal to v by r. So this value is nothing but omega. Omega is nothing but 2 pi nu. That is equal to bq by m. Or nu is equal to bq by 2 pi m. This is the frequency from which period can be calculated. Period nu is equal to 1 by t. Therefore 2 pi m by pq. This is actually a position. Are you clear now? Whenever a charged particle moving in a magnetic field. So I take this. So this is the thing I have given in the chart. Kindly make note of this. Nu or t does not depend on speed of the particle. Kindly nu bq by 2 pi mr or t is equal to 2 pi m by bq. So here v value is not comes. V cancels out, from which v by r can be modified as omega. Therefore, the speed does not depend upon the period or frequency. We least bother about the velocity. But the velocity depends upon radius. The previous v by r is equal to bq by m or r is equal to something. Therefore, what does it mean? The larger the radius or the speed of the particle is more, it attains a larger radius. A bigger circle comes means the particle are moving with more velocity. That is a Lorentz force, just now we have given. If a charge q moves in a region where both magnetic and electric field is there, in the previous Lorentz force I have given only in a magnetic field. Suppose the charged particle moving in both the electric and magnetic field, we have to add the electric field also. Therefore, E plus V cross B, called the Lorentz force. Velocity selector. What is a velocity selector region? The velocity selector, if you understand here, it is very much useful in the nuclear physics. That is called Bainbridge spectrometer, and also in the atomic physics, E by M, Thomson's method. If I take two metal plates, so that is a thing we have to understand. So, if there are a metal plate like that, if a charged particle enters, so it is given a positive, this is a negative. So this is, we are applying the electric field. So that the deflection is there. The deflection is there. I apply a magnetic field perpendicular to the electric field. So electric field E, magnetic field is B. Both are applied equally, magnetic field as well as the electric field mutually perpendicular to each other. What happened? So what is a, then only it comes to original position. So that means magnetic force, that is BQV, Lorentz force, always equal to electric force, E into E. The first unit you have seen. F, there are two charges. For E, only one charge. Therefore, E, F is equal to E by E into Q. Or Q, E is equal to F by Q, like that, E into E. So, from which this BQV, that is a magnetic force, electric force, E, E. Both are same. From which the velocity, or E means Q into E. This Q getting cancelled. Therefore, V is equal to E by V. So, this is an important formula for velocity selector region. Velocity is equal to electric field divided by magnetic field. That value comes. Whatever may be the value. That is that velocity. Any ion or electron or any charge which possesses the velocity E by V can able to cross this area. So this area is called velocity selector region. Any ion or any charge doesn't possess the value of velocity E by V, it won't be allowed. That is rejected. Only V is equal to E by V can pass through this region. Hence this region is called velocity selector region. So that is given BQV or QE E by B. Then cyclotron. The cyclotron is another effect that is called effect of current. What is a cyclotron? Cyclotron is an instrument used to accelerate the particle from which any amount of energy can be gained. So it consists of two metal Ds. So the metal in the form of English letter D, so it consists of two Ds that may be connected to the positive and negative potential. Very high alternating electric field. I take a particle to be accelerated, may be placed in between two Ds. Say proton. Proton we know positive charge. When the electric field is switched on, automatically this positive particle goes towards the negative D. So this is D1, this is D2. Now the particle moves towards D1 because the opposite charge attract each other. Immediately I apply a magnetic field perpendicular to the electric field. Because of this charged particle moving in a magnetic field always circular. So it makes a semicircular path. When it attains a semicircular path in D1, there it gains a negative potential. The D2 is connected to the positive terminal. Automatically it is attracted to the D2 with a longer circle with a high speed. I already told you that if radius is more, the velocity is also more. Therefore, because of this more velocity, it attains a longer radius. Like that, it finally comes out. Deflector plate. So, like that, the accelerating field. What is here? Here also the same argument. Because the magnetic force I have given BQV sin theta, here theta 90. The force which is responsible for circular motion, centripetal force. That is also mv squared by r, where m mass of the charged particle placed at the center, say proton, v velocity of the charged particle or radius of the circular motion. Therefore, m into v squared by r always equal to bqv. So here also we are getting v. Therefore, v by r is equal to bq by m. So just like we have seen like that. So this is actually a thing. V by R. We know already V is equal to R omega. V is equal to R omega. R omega is equal to V by R. So that is the value of omega. This omega is nothing but 2 pi by T. That is equal to BQ by M. Therefore T is equal to 2 pi m by bq. So this is the period of revolution. This is the period for a circular motion generally. In otherwise it can be argued other side also. What is the distance travelled by semicircle? The distance travelled by the semicircle is pi r. We know velocity is equal to distance by time. Therefore, time is equal to distance by velocity, pi r by v. The total time taken 2t. Therefore, 2 pi r by v. That is also we can argue. That is called 2 pi r by v. So that can be modified as 2 pi m by bq, because r by v can be 1 by w. 1 by w can be modified. Whatever may be the thing. Or frequency bq by 2 pi m. This frequency should be maintained. This frequency should be maintained. Then only it is possible for getting more energy from the cyclotron. So that what is the frequency value? 1 by t. That is nu is equal to bq by 2 pi m. This is actually a frequency. So we have to maintain this frequency. We have to keep m constant, b constant, q constant. So what does it mean? The maintaining of magnetic field m. So when time increases, it attains a larger radius. If it is a larger radius means the area of the circle going on increases. The maintaining of magnetic field constant for bigger area is not possible. So, when the time increases, the speed of the particle increases, it attains a larger circle. When it attains a larger circle, what happens? B we cannot maintain constant. If B may not be maintained constant means frequency value changes. Therefore, cyclotron not working. Are you able to follow what I say? The another thing also, the mass is constant. Generally, according to the classical theory, we are taking the mass of the body remains constant. But according to Einstein's theory, the mass of the body also varies. Because the velocity of the body going on increases, the mass of the body also changes. We know m is equal to m naught divided by root of 1 minus v squared. We know already m is equal to m naught divided by root of 1 minus v squared by c squared. Where m is the mass of the body in motion, m naught is the mass of the body at rest. When the body velocity v going on increases, the mass of the body also increases. Therefore, it is not possible to maintain m and q constant. So that there is a limitation. What is a limitation? The limitation these are all. Only we can accelerate proton. We cannot accelerate electron. Why the negatively charged particle cannot be accelerated by using cyclotron? That is also useful question to you. Electron, for a small variation of velocity, there is a large variation in the mass. Whereas other particle, whereas proton, not like that. Only a large variation of velocity, it attains a small variation of mass. Whereas electron is concerned, even a very small variation in the velocity, there is a large, it shows a large variation in the mass. So that electrons cannot be accelerated by using cyclotron. So these are all some drawbacks of cyclotron. But anyhow, if we avoid this limitation, we can use cyclotron for accelerating the particle. The principle of working is charged particle moving in a magnetic field. Very similar derivation. So that is I given that. Device to accelerate charged particles to high speed. If R is the radius of the chamber, then V is equal to VQR by M. Kinetic energy, we know half mv squared. Therefore, half m b squared, q squared, r squared by m. This is the energy of cyclotron. So these are the things we have to understand it. The Hall effect is another important topic. We will discuss in the next class. This is a best place to stop. The Hall effect we will see in the next section. Thank you.